Hey everyone. So I'm here with NFT Storage, which is a project of Protocol Labs, the creators of Filecoin and IPFS. For me to get like a sense of the audience, who here is familiar with IPFS? All right. Who here is familiar? Who here is like created an NFT? Okay, cool. So what I'm gonna do is just give like a overview, and this may be more appropriate. It's a little bit intimidating for me to tell people who know about NFTs and IPFS, all this stuff. But for folks who are a little bit newer to it, I'm gonna be like, these are the things that exist that you're gonna have to deal with if you're gonna become an expert at this stuff. And I'm gonna focus on the ETH blockchain and kind of talk through what's in the NFT ontology. And then after that, I'll talk a little bit about some of the capabilities, the ease of use stuff that NFT storage is doing for our, for this use case. So in the Ethereum chain, there's all kinds of stuff happening. People are trading ETH, people are trading other tokens, and there's a bunch of little standards in that ecosystem around the way that you structure these tokens. So like an ERC20 is the name of what you would look for a custom token like a DAI or something like that. ERC 721, you can Google that and see how all the metadata for a NFT is managed. ERC 1155 is if you want to do like a universe that has non-functional tokens as well as like fungible tokens in the same smart contract. And so all that is terms for like the EVM compatible world. There's going to be similar stuff in the ecosystems for the other chains. So I think if you are learning NFTs, learn it on ETH because there's so many alternatives, ways to take that same knowledge and use it in another chain. But also the stuff you learn for ETH is going to apply to the other chains, even if it's like by way of this is different. Understanding how to organize royalties or rarities or your metadata or your images, a lot of that is going to be the same regardless of which chain or ecosystem you're in. So we talked about the token. That's the thing that is either fungible or non-fungible and is swapped. Well, tokens belong to collections typically, and when you get technical about it, a collection is really a smart contract. So you can have like multiple collections sharing the same smart contract, but you're typically going to have one smart contract per collection. And so that'll be the contract that's managing the sales of your alien friends or your bored apes or whatever. So when you mint an NFT, what happens is you call that smart contract with the funds that you're buying it for, and the seller, signs the thing that says run it, runs it, creates a new token with like token ID 3, let's say, in that collection, and assigns that token to being owned by the purchaser. So it's worth thinking about how those token names are namespaced within your collection. So we'll talk in a minute about managing the metadata and images and how you're going to want to embed those inside URLs that your smart contract can talk to pretty easily. But before we get there, we'll talk a little bit about smart contract development. Who here is like writing Solidity code or otherwise a smart contract developer? And who here isn't but wants to be? Okay. So the thing to do if you want to get into that, first, just to gain the experience, use an already hardened, already like peer-reviewed smart contract from your very first NFT that you're going to sell, which is going to be like no code, click on OpenSea or Rarible or Super Rare, one of these marketplaces, and drop your image in there and be like, I did my first NFT. You're going to want to do that. That smart contract, you didn't have to write at all. You can go look at it, you can review it, kind of understand what behavior is in there. And if you're like the 80% use case of you just want to trade static images with like a fixed royalty and not trying to do anything innovative in there, then use that smart contract. It's only introducing risk to write your own, but you should be empowered. You should like learn what's inside smart contracts, because then it allows you to know what you could do, and maybe as an artist even get more inspired about what the possibilities are. So the next step for like going down that road would be to use a smart contract building toolkit. Use something like Open Zeppelin to give you the components that have been vetted that you can compose in a way that will give you the custom behavior you want. Whether that's making some slice of the royalties go to a charitable cause or whatever. So you can use custom smart contract development to write that behavior into your NFTs. And even just by composing capabilities in smart contract builders, you can get pretty far. You're probably less likely to write a bug if you're new to development doing it that way than by writing the code raw. The next step to get deeper in is just to go write Solidity or Rust and write your own smart contracts, and don't put a bunch of money into them until you have a developer you trust to review them with you. But those are your 3 levels of getting into smart contract development. So don't just use one that already exists and works. Learn how it works. Use a builder that'll help you see what the moving parts are, then actually write the code, and maybe keep it on testnet and watch your see how easy it is to steal funds from yourself or whatever before you get into real trouble. So, all right, so we've got a token that was generated by a smart contract, and the thing is block space is expensive, right? Like block space is like the product of a blockchain, and the more popular the blockchain, the more expensive the block space. So you're probably not going to put your whole NFT on there. You're going to want to put the smallest bits of information that makes sense to put on the chain. So let's say the smart contract identifier, the token identifier, and then the third thing that seems to be needed is like a base URI, right? A place to look for that token identifier. And what happens when you're going to like dereference an NFT when you want to view it, if you're going via the chain to find it, is you've found that ERC 721 and its metadata, or rather its on-chain data is going to include with the smart contract a base URI and its token ID. And then the smart contract will typically have a function that can compose all that stuff into a URL. And so that can be written by you based on what your tech stack is. You can imagine that function might say, okay, take example.com / and then put, my collection ID and then /2.png if your token ID is 2. And so that way you can easily have thousands of tokens, but not very much information on chain. You just have to have that token number and that base URI. It'll combine it, and then you go load this up, and it gives you more information about the metadata, about the NFT. So we'll talk more in a second about what those URLs can be. But like the mechanism that we're all familiar with is you've got a URL in your browser, and there's a / and you change like number 3 to number 4, and you get the other one. So just like keep that in mind. So the thing that is actually referenced when you first do that fetch is the metadata. So the metadata is going to be typically a JSON file, machine readable but human readable, with things like the traits and the rarity and kind of other project specific things that you want to add to the metadata for your NFT. But the most important thing that's going to be in there is the actual link to the image or the asset or the video or whatever is the content of that NFT. So again, that's going to be a URL. And now here's the part where I can talk about the risk that all the URLs introduce. One of the reasons we like the blockchain is because it's not censorable. It's because if you get the data from a block, you know that you got the same data in that block as the whole rest of the world. But as soon as we're talking about like a example.com, then somebody could forget to pay the bill on their hosting for their NFTs, or they could get hacked, or they could have their they could become malicious or whatever. They could get bought by a different entity that doesn't care about that project. All sorts of things can happen to a centralized URL because they're location-based identifiers, right? If I'm going to news.com/latest, it's really about like, where do I go, and then ask them for whatever the thing is they want to give me. And that could change based on what news.com wants to do. So for those of y'all familiar with IPFS, you might see where I'm going with this. What's the problem with those centralized URLs is that all these things, they're just not actually very sticky links. They link to stuff that can change. So in IPFS, the way that the links look is that they're based on a fingerprint of the content. It's a hash of the content. And so when you go to dereference an IPFS content identifier, you just ask the whole internet, the whole network, hey, does anybody have anything with this fingerprint? And whoever gives you the answer fastest, you check if the fingerprint is right, and if it is, then you have the data. So what's cool about that when you're doing stuff on chain is you don't have to worry about somebody modifying something or getting rug pulled. Like, the worst that could happen is the data is not available. But if you get data, you can tell it's the right data. There's no ability for somebody to like censor the data or modify it in flight. So what are we going to do with that in this context? We can use these URLs as the metadata URLs. So I was talking about like base URI /2 dot whatever. That base URI can be your IPFS CID, which is just a long string as a hash. And so if your base URI is that, and then inside of that CID is your collection of images and metadata, then just by appending 4.json to your base URI, you have something that any web browser can pull back the data, or via the IPFS network, you can pull back the data from the decentralized network. So what that means is that it's completely compatible with the whole stack. Like, anybody who built this mechanism imagining that it was all going to be centralized URLs, well, the IPFS CIDs work just great in there, if not better, because you don't have to worry about the rug pulls and whatnot. So yeah, I guess the analogy that I like to remember that is like, pretend you wanted to get a book. Pretend you wanted to get a copy of Catcher in the Rye, and your answer to that was you have to go to Boston, and then you have to like wait till the next morning because the office of the publishing office isn't open until 9 a.m. And then you go and you get your copy of Catcher in the Rye. That's what a centralized URL is like. Whereas a content identifier is more like going to your nearest library and picking out the book by its ISBN number. So it just makes it so you're not dependent on a particular host or on hosting your content with one versus many hosts. You have the ability, for instance, and I'll talk about our product a little bit at the end, but for instance, when you upload to NFT storage, we turn around and upload that to a bunch of the popular IPFS hosts like Pinata, et cetera, to make it so that if we disappear, your data is still available. You won't know the difference, for the most part, even if we did disappear. So a couple of things that if you're like thinking about how hashes work and these immutable content identifiers, then you're going to be like, well, what if I wanted to have an NFT that changed over time? Like, how am I, going to do that? And if you were using a centralized URL, if you control the server, example.com, you can always just upload a new image whenever you feel like it, and you'll get that behavior. But you'll also spook out your customers because you're changing the thing they bought without any on-chain record of that change. So instead, how can we do this in a way that is actually, fits with the grain of what people want with crypto, being verifiable, having the ability to go and get that data from other places and whatnot. So there is a IPFS feature called IPNS, which is essentially a name service that's written for a cryptographic world. So the name is actually like a public key, essentially. And then there's an aliasing system that the private key can say, hey, like, first, like, give this public key a human-readable name, like a .ens name. And second, like, update this public key to point to different content over time. And so you can get a verifiable list of what those used to be. And then now rug pulls are impossible, because if you wanted to, you could roll back to an earlier version of that content. Like, let's say the artist replaced the content with like a joke content or something, and you preferred version -1, you could do that. And so that allows for dynamic NFTs. In the larger context, it's worth noting that like currently the performance is not going to be like frame rate performance on making those changes, but we're working on that because we know that that's exactly the mechanic that needs to happen in games, where like a object might get modified because of in-play action, and you want to have that reflected in the data model. So the idea is you could use that same code path for like chat rooms or in-game play. That's kind of more roadmap action. So who here has ever generated like 10,000 NFT images all with variations and stuff? Cool, okay. There's a bunch of different ways you could do it. You could do it yourself. You could write your own software to do it. I just want to like do a shout out for if you want to get started playing with, let's say you're just a hacker, or you're not an artist, but you want to have like some files around to mess with. Or let's say you're an artist and you're really interested in making like a profile photo collection with rarity and traits. Go look at Hashlips. I'm just a Hashlips fan. I like watch their YouTube all the time. They've got great videos about their tech stuff, but then they also have these really cool scripts that will like, you can give it some alpha background transparent PNGs in layer collections, like this folder is the hair and this folder is the teeth or whatever, and it'll generate you as many permutations of your layers put together along with metadata that includes the traits and the rarity. So go Google Hashlips and tell them that NFT Storage sent you. Yeah, we're using them a lot for inspiration about like, what should we expect that it is that users want to upload? It's going to be things that look like they came out of that. And now I guess I'll switch gears a little bit and talk about how you can use NFT storage in your NFT projects, which you might be working on today. If anyone's doing uploads in their application, this should be helpful for you. And even on the I got this done, on Saturday afternoon, and it was fast enough because we saw it working yesterday for some of the teams in the other room. So, like, we're all hackers, and we can go write some cool like Node.js script to go grab an API token and do this and upload that and check your errors and retry it. And, like, sure. Or you can download NFT up from right now we just released it on Monday, so you'd have to go to the blog on NFT storage and download it. You download it, drop it in your applications folder, launch it. It'll ask you for your API key that you can get from the NFT storage website. And then it gives you the interface. Like, we built this for artists, but as a coder, I don't want to have to think about stuff. So drop your files in. In this case, I'm just illustrating that it'll take it'll take a collection of folders at the top level if you want. You just drop whatever data structure you want on there. It'll do its business to get that data up to our cloud, where our cloud will then, like I said, go put those CIDs onto a bunch of different IPFS storage services, as well as into our own IPFS Elastic provider, which is a port of IPFS written for the AWS stack. So a kind of industrial scale IPFS provider. And then when that's all done, it'll give you the link that you want to click where you can go see your data, or copy and paste that IPFS URL into your smart contract based URI like I was mentioning earlier. And now when you're minting NFTs with that smart contract, it'll know to look inside of that folder structure to find your images and your metadata. So this is what the upload ends up looking like. That hopefully is a good start. I guess what I hope the developers start to feel like empowered by with this pattern is, rather than like let's say I had some application that had a complex thing that the user had to compose with like a handful of files, like you were accepting uploads of like a 3D metaverse world, and there was going to be textures and shaders and models and whatever, and they all needed to get uploaded. and you had some data structure that your application was looking for, well, just have the users compose that, right, on their desktop, and then drop it on here, and you'll get it here, and all the slashes and stuff are just where you would expect them. So now they can just give you this CID, and you can browse into it just like, because you understand, images slash, thumbnails slash whatever you told the user to put in. So that can be almost your API contract, is arrange the files like this and drop them on here. The other thing worth noting is that it's possible to make it so that rather than uploading to like the end user's account, this can upload to your application's account. So you could provision an account and then give users temporary keys to upload into your account. So that's what larger marketplaces and galleries do when they're using us for their uploads. And then to wrap up, I guess I'll just say we've been talking a lot about NFT storage. My team is building this stack that we're using for NFT storage. We're also using basically the same stack for Web3 storage. The main difference is NFT storage is free. It's a public service we provide for NFTs. Web3 storage, we have like a revenue model where you end up like staking Filecoin essentially to gain access to certain amounts of capacity. So Web3 storage, same APIs, but if you wanted to do like a game or some other application, especially optimized for futuristic IPFS stuff that you kind of couple steps up the learning curve, but inside of those IPFS files, there's these graphs, IPLD graphs. Like a lot of times it'll just be used to maintain the directory listing and the file names and stuff, but that same thing can be used to maintain any data structure that you want, like an index of whatever, the latest messages in a chat room, the structure of a Google document type thing. So users can be pushing those graph diffs into Web3 storage just like their other IPFS blocks, and we'll replicate them around and give you all this high performance, running on Cloudflare cache and all that as well. So yeah, do check that out if you want to get into something that's a little bit more programmable than NFT storage. And thank you.